Okay, so periodic rate or rate per period is the APR, APR divided by the number of compounding periods. So if it's monthly, it's divided by 12. If it's semi-annual, it's divided by 2. Quarterly is 4. Daily is 365. So our examples here, they so the um, our rate per or periodic rate or rate per period in 8% compounded quarterly is 8 divided by 4, so that's 2% per quarter. So if it's monthly, it's 8 divided by 12, so that's 0.667. Actually, that's 0.666, and it goes on forever. And one of the things to be careful with is when you do calculations, especially when they're like prime numbers, numbers that never end. The like for example here, just enter this into the calculator for when you're doing your calculations, and I'll talk about this more later. But if you do, for example, if your calculator, you do this and it shows 0.67 and you type in 0.67, you will get a rounding error when you do your calculation. We'll talk more about this later. So then next is a formula that I showed you. So this is your APR. I should edit these slides, but anyway, so and then M is the number of compounding periods. So for 1.0 for 8% compounded monthly, that would be 1 plus 0.08 to the 12th power. And our calculator, that would be second high conversion or interest conversion. So then it's going to display nom. And whatever you typed in there last tends to stay in there. So but this would be 8. And then we would go to CY, which happens actually is up, but so second. So CY, so that would be 12, enter for monthly. And then we go actually up again to EFF and hit compute. And so 8.330. So if we recall if we have annual compounding, it's 8%. If we did quarterly, it was 8.24%. Monthly was 8.30, and daily was 8.33%. So basically what it's saying is any compounding is far superior to annual compounding. So when we're talking about investments. So the example here, another calculation of EAR, effective annual rate for an investment that pays 12% compounded monthly. So that's one APR again. So 1 plus 0.12 divided by 12 to the 12th power minus 1. So that's 12.68%. So if we were to enter this into our I conversion, that would be second ICONV, and NOM is 12. Compounding periods per year is 12. And then effective is going to be the 12.68, but I'm going to go ahead and enter into my calculator. So second I conversion 12, enter, go up to EY or CY, sorry. CY, and that's 12. Enter. Go up to effective and hit compute, and you get 12.68%. Won't show the percent sign. But anyway, a whole lot easier than using the formula. If you want to use the formula, you're more than welcome to. So loan amortization is the next topic. So a loan is repaid in equal payments over its life. Your car payment, your mortgage payment, your student loans, any of those will qualify for this. Portion of the payment represents interest, and the remainder represents the amount repayment of the amount borrowed or principal. So amortization schedules use, you'll see them in your mortgages, car loans. You probably received one with your once you start paying your student loans off. So, so amortized loan for in this case $33,000, 6.5% requires 3 equal annual payments. I'm going to calculate this monthly as well. So we'll go to the next slide. So with our calculator, it'd be with the annual payments would be 3N, 6.5 IY, and then 33,000 would be your present value, and then 0 future value. That entering this 0 tells it that you're paying the loan off at the end of the 3 years, and then compute payment, and that would be a negative $12,460. If we were to do this as a monthly payment, for example, our N would be 3 times 12, or 36. So that's N. IY would be 6.5 divided by 12, which I don't know that number, but 6.5 divided by 12, that's 0.54. The present value is still the 33,000, and then 0 future value. So the compute payment, that would be negative $1,011.42. So you $33,000 loan for 6.5% for 3 years would be $1,011.40. But back to our example, the amortization schedule looks like this. We start out, we borrowed $33,000. We're going to make this payment at the end of the year of $12,460. Our interest is the 33,000 multiplied by our 0.065. That's 2145. We subtract that, and the difference between those two is our principal repayment. We subtract that from our beginning balance, and this becomes our ending balance, which is also our beginning balance. Make another payment after a year at $12,460. The interest is $22,685 times 0.065, which is $1,474.53. And so we subtract that to get our repayment of principal of $10,985. Our remaining balance after 2 years, $11,699.53. The final year, we make the same payment at the end of the year, the $12,460. Our interest is $11,699.53 multiplied by the 6.5%, or 0.065. So we subtract that. Whoops. We subtract that. So these are we take. So we we have $11,699.53 to pay off our loan. So we, at the end of the 3 years, we have a zero balance on the loan. That is the end of chapter 4.